Well, thank you for joining me. I'm just going to look at some trigonometry of some cofunction identities. And what we're going to see in this segment is we're going to see angles which are written, instead of 90 degrees, it's written as pi over 2 radians. So when you see pi, my computer will actually work. I don't know if it's going to. When you see pi over 2, that's radians, and that's the same as 90 degrees. So there's a, if I was to put an origin and a semicircle, that's the radius, and that's the radius. And if this arc length is also the same as the radius, that's a special angle. We call that angle, it's a little bit less than 60 degrees, but we call it 1 radian. And in 180 degrees, there are 3.1415. There are pi radians, and that's pretty much where pi comes from. So when you see 90 degrees, that's pi over 2. Okay, so what we're going to do through here is just choose an angle that will be positive. Choose an angle that cot theta is positive. Now cot is 1 over tan of theta. And tan is positive in quadrant 1 and quadrant 3. So theta is an angle, either a quadrant 1 angle, which is like acute, is in quadrant 1, or theta could be a quadrant 3 angle. Otherwise, you would get a negative number here instead of a positive. Now we're after tan of 90 minus theta. We're after tan of 90 minus theta, not theta. Okay. 90. Sorry about this, my computer's not keeping up with my writing. 90 minus theta. Well, the thing about this theta and 90 minus theta, it's important to know that whenever you see theta and 90 minus theta, they are the two angles, they are the two other angles in a right angle triangle. So let me just show you what I mean by jumping across to another. Just briefly, when you have a triangle and this angle is 90, if this is theta, then this other angle is simply the complement angle is 90 minus theta. So whenever you see pi over 2 minus theta or 90 minus theta, you think of the complement angle of theta. So if theta was 30 degrees, then 90 minus theta is 60 degrees. They are complement. And the thing about complement angles, the sine of theta will equal, because sine is opposite over hypotenuse, will equal the cos of the other angle, the complement angle, because cos is adjacent over hypotenuse, the same sides. And that works with things like tan of theta is opposite over adjacent, and cot of the other angle, which is cotangent, is adjacent. I'll put this in blue. Ooh. Come on, give me a blue. Thank you. Is adjacent over opposite. So it's the same sides. Okay, so let's go back. That principle is pretty important in this question. So if I draw a triangle and I put theta here, this one is 90 minus theta, or pi over 2 minus theta. Now cot of theta is adjacent over opposite. So if that's 0.67, this would be 1. So adjacent over opposite equals 1. Therefore, what's tan of the other angle? Opposite over adjacent. It's also equal to 0.67. And the thing about it is, if cot is positive, that means tan is also positive, because if cot is positive, then tan is also positive. So let's pick some angles here just to prove that. First of all, let's pick, if theta is acute quadrant 1, if theta is in the quadrant 3, such as 100 degrees, 200 degrees, then that's also positive. Now, if tan of 90 minus theta from acute angle is also positive, and tan of, say, 90 minus an obtuse angle, we would get negative 110 degrees. Negative 110 degrees is in the third quadrant. So it's also positive. So that wraps up this question. We've finished that question because we know it's going to be positive. The number is the same, 0.67, and the sign is also positive.